Welcome back to the course Discrete Mathematics. This is the third presentation and I'm going to talk about the content of the course. What is the course about? What are we going to discuss in the course? And in this video I will give you an overview of the different chapters, the different parts that are included in the course. The content of the course is interesting to understand at this moment, so we have an idea where we are going and how many sections of chapters that we will consider. First of all, we look at the foundations of logic and proofs. Here we're going to introduce the elements of logic, propositions, compound proposition, and proofs. Proofs are very important in discrete mathematics and in IT because when we want to use an algorithm or when we want to prove or when we want to use a kind of formula or some logical combination, we have to be sure that it is correct in all circumstances. If there are exceptions, it may lead to problems that we may encounter later. So proofs are very important with what we're going to do in the remaining parts of the course. Logic is also very important because computers are logical machines, programs are based on logic, and all those things have to be understood very well by people who want to program computers or who want to develop hardware. Now, the second part is about basic structures. What are the structures that we are using in IT? What type of structures do we encounter? And what are the properties of these structures? And where do we use them? And what is their importance? We also look at algorithms, and algorithms are very important. Algorithms are kind of programs that, for example, help you look for data on the internet, or they help you to order some data. What are we going to look into when we look at algorithms? First of all, when we have an algorithm or when we develop an algorithm, we want to see if it's applicable in all circumstances. We have to prove the validity of the algorithm. Another part in algorithms, which is very important, is to find out how long it takes to complete the algorithm when the number of data are increasing. You all know Google. Google is using a very strong algorithm, what made it so powerful, and that algorithm is dealing with millions or trillions of data. And the algorithm makes it possible to present this data to you very quickly. If it would take too long, people wouldn't like the algorithm. We want to finish a query. We want to apply an algorithm, for example, to link donors and receivers of organs. A very complex idea, a complex item to consider. And we want to have that algorithm, or we want to have our answer as long as the question is still valid. When it's too late and you get your answer, the algorithm has no sense. We also look at number theory and cryptography. Cryptography is very important. How we do this, we use prime numbers. We look at P and NP problems. So we look at polynomial problems, not polynomial problems, and NP problems are very important in the field of cryptography. The fact that cryptography is an NP problem using those prime numbers makes it so interesting to code the information we are sending and make it only possible by the correct receiver to decode that information and read it in clear. Another element what we are looking at is induction and recursions. We have to identify what they are, how we use them in the different programs. We continue with discrete probabilities. What are they? What are the elements that we can use from them? We look at advanced counting techniques. Then we continue with relations, different relations between parameters, between data. We also consider graphs. Graphs theory is very important. Look at the traveling salesman problem. There are a lot of graphs problems that are important in IT and that can be used to resolve problems. We look at trees, spanning tree, all kinds of algorithms that we can use using trees. Also very applicable in many fields. And like I already stressed, all these things will be very important for you to understand to resolve these specific problems. We continue with Boolean Algebra and OR and NOR gates, how to find out how the systems work, the logic of those systems. And finally, we finish the course with modeling computation. You see, there's a lot of things that we are going to consider. We will be looking at those problems chapter by chapter. We will have a lot of videos. There will be different sections, different sessions, and everything will be organized in a logical way. Of course, we're trying to teach you logic. The course should also be organized in a logical way. This was the last video of the introduction. It's a short introduction, only 3 videos. And after this video, we're going to start with the first chapter. The first chapter, which is about logic and proposition. So we're looking at all these elements in the next chapter. That will be chapter 1, logic and proofs. That was all for this part. You finished one section. Still a lot of things to do, but you're going in the right direction. And I'm looking forward to seeing you in the next video. Thank you and bye-bye.